Welcome to Graphing Quadratics number 5. Today we are going to explore or learn how to transform, which means move or change, a parabola by changing the values of a, h, and k. So when we graph the most basic quadratic equation, we call the most basic a parent function. So a parent function is the most basic form of a function. It will generally go through the origin 0, 0, and this is the equation, the graph of your most basic quadratic. So that most basic equation is y equals x squared. That meets the bare minimum requirements to be a quadratic. In order to be a quadratic, you have to have an exponent of 2 on the variable, and it can't be more than 2, and that's it. There's no a, there's an a, it's 1, but b is 0, c is 0, there's no h, there's no k. This is the most basic that you can possibly graph. So a is 1, and the vertex is located right here at the origin, 0, 0. So the parent function, that's this, the parent. The parent means that no transformations have occurred. No transformations have occurred. That is the most basic. So on my Desmos graph here, I have graph for you, they're the same, but they are the parent function of a quadratic y equals x squared. And what we're going to do is we are going to play around with the different variables a, h, and k, and we're going to figure out what messing with those numbers actually does to our graphs. So a vertical translation, you remember what translation means. Translation just means that you take something and you slide it up or down or to the left or to the right. So vertical means up and down. So a vertical translation is going to move the graph either up or down. So the way that we do that is we change the k value. So I want you to watch what happens if I make x squared plus 1 happen. So what just happened here to the graph? It moved up 1 unit. So if I make that a plus 4, then that means that my parent has moved up 4 units. So in order to shift a parabola up, that means that this k value right here needs to be a positive k value. It will move your equation up. So an example would be y equals x squared. What did I just do? Like plus 1 is fine. So that means it would move up 1 unit. So I bet you can then think, okay, well, how am I going to make it move down? Well, what if I change that positive 4 to a negative 4? Now this green quadratic just got moved down 4 units. Or perhaps, how about 10? Okay, that whole quadratic just got moved downwards 10 units. So in order to shift the parabola down, then that means that we need a negative k value. So my example might be x squared minus 10, which would move your whole parabola down 10 units. All right, so let's describe the transformation. So x squared is the parent, and then I'm adding 3 to that. So that means that your vertex is going to move up 3 units. So that means that your vertex, which always starts at 0, 0, it is going to move up. That's the y value. It is going to move up 3 units. So that means that the vertex of this, and you know there's no h here, so h is 0 and k is 3, so 0, 3 is the vertex. So describe each transformation. That description would be this. It moves up 3 units. All right, let's look at the next one. X squared, that is the parent function. And then we're going to take that parent function and we're going to subtract 2. So that means that we are taking the vertex and we are moving it down 2 units. So the vertex started at 0, 0 for the parent, and then we are moving that downwards in the y direction, which means our new vertex is at 0, -2. And the transformation is down 2 units. So that is a vertical translation. Moving to a horizontal translation, horizontal means that we are moving to the right and to the left. So let me go back here and oops, that's not what I wanted to do, but oh well. Let me get rid of that and go back to my parent function. I'm just going to copy and paste that here. Okay, so looking at our parent function, we need to move things to the left and to the right. So think about your vertex. If moving the k made it go up or down because that represents the y change, the y value, how are we going to get something to move left and right? Which direction is left and right? Isn't that in x direction? So that means that we would have to change this x value. And remember that the vertex is at h, k. So in order to get a horizontal translation, we need to move the x value, which means that we need to be changing the h value. H is attached to x, which is going to influence its movement in the x direction, left and right. So please remember that when we are dealing with h's, h is opposite. Don't ever forget that. H is opposite. So let's think about that for a second. If I want to move something to the left, my gut tells me that subtraction, right, would be to the left. But it is actually opposite, which means in order to go to the left, I have to be adding. So that means that x plus h squared, that plus h is going to shift our stuff to the left. So it should be opposite. Usually when I think plus, I think in the right direction, which is actually going to go opposite, and it's going to move it to the left. And then likewise, when I think that I need to move to the right, I need to do the opposite of that, which is going to be x minus h. If you were going to make a mess up on your translations, this is going to be where you do it. Students forget to do the opposite. So remember, I can always check my graphs and I can always compare them to one another. So if I do x minus 2, my gut tells me that minus 2 is going left, which means it is actually going to the right. So this is going to be a right shift of 2 units. So that means that my vertex, which was at 0, 0, is going to have to go to the right. So that's a positive 2, comma 0. Now I can check that on my graph. The green graph is going to be my parent, so that's where it starts. And then I'm going to take this equation and I am going to modify it. I am going to make it x minus 2 and then square it. Oops, that's not a square. Shift 6, square it. So if this is my original and I do x minus 2, that is going to push my graph right 2 units. Let's take a look at number 4. I have an x plus 6. So my gut tells me plus 6 is to the right, which means it's going to the left 2 units. So that's going to take my vertex for the parent that starts off at the origin 0, 0, and it means it's going to take it left 2 units. So my vertex is now going to end up at negative 2 comma 0. So watch, I can check myself in Desmos. I'm just going to flip this to plus 6. I don't know why I wrote 2. I was still thinking this one. I'm sorry. That is left 6 units. I apologize, which means that that's going to be a negative 6. So if I look at this vertex here, I am correct by saying that it was supposed to be at negative 6 comma 0. So vertical means the y direction up or down. So that is influenced by k. Horizontal means x direction, left and right, and that is influenced by h. All right, so check it out. It says describe each transformation, sketch a quick graph of the parabola. So what I'm going to do is I am going to write down the transformations made, and then I'm going to show you one at a time the transformations on a graph, just a quick sketch, and then I'm going to use Desmos to check my final answer. All right, here I go. So my gut says left 2, but I know that's going to be right 2 units. This says down 4 units. All right, so my original graph, my parent, should be like this through the origin. And then I'm going to take that to the right 2 units. So that means that it's going to move here. So now my graph is going to be looking like that. And then it's going to go down 4 units. So 1, 2, 3, 4. So my new vertex is right here. So my graph should be looking something like that in its final place, with the vertex being at positive 2, because that's the right 2, and then down 4, which means negative 4. So let me check this answer. Dang it, I don't know why I just got rid of that one. That's okay. All right, so parentheses, x minus 2, square it, and then minus 4. So my graph here goes through the point to negative 4, which is exactly what I said, and there is my parabola smiling, opening up. All right, let's take a look at number 6. So number 6, that says, my gut says right 3, but that's opposite. It is left 3, and that says down 1 unit. So let me do a quick sketch. The parent goes through 0, 0. I'm going to take it to the left 3 units. So that would be 1, 2, 3. So now it's kind of looking like that. And then my final graph is going to get moved down 1 unit. So now my final parabola is looking like that, with a vertex at -3, because I went to the left 3, comma, -1, because I went down 1. So let me check that here. I'm going to switch this to a +3 and this one to a -1. And here is my graph with a vertex at exactly what I said, -3, comma, -1, and it is a smile. It is opening up. Okay, so let's talk about dilations. If you remember from our transformations back at the beginning of the semester, you know that a dilation is either an enlargement or a reduction. So if you think about a U and I shrink it or compress it, it's going to go like this and it's going to get skinny. If I enlarge it or widen it out, then it means that my parabola is going to open up like this. So that means that I have two options. If it compresses like this, it's going to get tall and skinny. If it is stretched or widen, it's going to get short and fat. So this is called a dilation. So a function has been dilated when it has been stretched. S-T-R-E-T-C-H-E-D. When it's been stretched away from an axis, or if it has been shrunk towards an axis, and sometimes people say compressed instead of shrunk. So this happens when you start to change the A value. So if I make my A value big, so if I make my A value greater than 1, I want us to watch and see what happens to the graph. So let me just go back to an x squared, and I'm just going to start playing around with the A value. So right now the A value is 1. Let me copy, and I will mess with this one. So the parent is green, and the one that I am messing with is blue. Okay, so what if I make it a 2? What if I make it a 4? What if I make it a 10? What is happening the bigger this number gets? The skinnier, right? The taller and the skinnier that parabola gets. So if I make my A bigger, that means that the graph is getting tall and skinny, which we call a vertical stretch. Right? If it's getting tall and more narrow or skinny, that means that it's being stretched like this. If you were to take a gummy bear in your hand and stretch it, okay, vertically, it would just get really tall and skinny. All right. What if I take my A's and I make them smaller than 1, but not so small that they go negative, because I already know that a negative is going to change my parabola from a smile to a frown. So that means that I can't go past a 0. Okay, so let's do that. So I need a number that is bigger than 0, but smaller than 1. How about 0.9? Or 0.7? Or 0.5? Or 0.1? Do you see what is happening the smaller this A value gets? The smaller this A value gets, the shorter and the wider my parabola becomes. So the smaller my A value gets, the graph is getting short and wide. So short and wide is going in the X direction. So we would call this a horizontal stretch. So if you took that gummy bear and you pulled them to the left and to the right, that gummy bear would just be getting shorter and fatter. All right, number 7 says, describe the transformation of this. So I'm just going to go in order as I see it. So the first thing I see is the A value, which is 5. 5 is a bigger number than 1. So that means that we are going to get a vertical stretch by a factor of 5. And then I'm going to go to this. So my gut tells me that I go to the left, but I actually go to the right. So A is up, I'm sorry, not A, try again. H is a positive 3, and it's going to send this thing to the right 3 units. And then I come here, that is the K value, and that is going to make my graph go up by 2 units. And you can always check yourself, and you can graph one thing at a time. So here is my original function. If I throw a 5 in front of that, it just stretched vertically by a factor of 5. And then if I take this and make it an x minus 3, that just moved it, see, to the right 3 units. And then if I add a 2 to it, it went from 0, 0 back to the right 3 units, and then up 2 units. So you can see that my transformations are matching what this equation says. All right, the last that we need to talk about is the thing that we already know. We already know about reflections. So the reflection of a smile as it gets flipped over is just a frown. So a reflection means that we are just flipping, we have flipped the parabola over the x-axis. So anytime the A value is negative, we have performed a reflection over the x-axis, which is going to make it a frown. And a negative A value, if it's a frown, that tells us that our vertex point is now on top. So it is now a maximum point. All right, last 2 examples here. Write the equation of a quadratic in vertex form for each transformation. So let me write for you what vertex form is. Y equals, can you do it on your own? A times the quantity, x minus h, square it, plus k. All right, it says a vertical shift 5 units up. That means that k is a plus 5. Going up means k is plus 5. A horizontal shift, that's going to be h, 2 units to the left. So that's h. And a reflection in the x-axis. So that means that we are going to have a negative a. All right, so let me write that in vertex form, and I'm going to put it all together. So my negative a And then I have to go to the left 2. My gut tells me that's an x minus 2, but it's actually opposite, x plus 2, square it, followed by a plus 5. So that is your final answer, this equation right here. So that's the reflection, that's moving it 2 units to the left, and that is moving it up 5 units. Last one, pause it and give it a shot. It says that we want a horizontal stretch by a factor of 1/3. So that means that A is going to be 1/3. We want a shift down 2 units. That means that K is going to be -2. And then we want to go to the right 3 units. So that part is H. All right, let's write our final equation. So y equals A, that's going to be 1/3 times, I want to go to the right 3 units. My gut says x plus 3, so I have to do the opposite, x minus 3, square it, and then a K value of -2. So that is your final equation here. And you can graph both of those equations on Desmos, and you can check to make sure that these transformations are happening.